Welcome to a lesson on scale factor. The goals of this video are to define scale factor and then use scale factor to sketch a proportional model. Scale factor is similar to unit scale except no units are given. Scale factor is a ratio comparing the scaled measurement to the actual measurement. So for example, if we take a look at these triangles here, if the original or actual triangle was the one in the middle, and let's say we had a scale factor of 2. Well, if the scale factor is 2, the ratio would be 2 to 1. So the scaled triangle would be twice as large as the original, which would produce this triangle here. Now if the scale factor was 1/2, that means the scaled triangle would be half the size of the original, as we see here on the left. Let's go and take a look at an animation of scale factor. When the scale factor is larger than 1, as we see here, the scaled triangle is larger than the actual triangle. And if the scale factor is less than 1, the scaled triangle will be smaller than the original triangle, as we see here. Notice that the triangles do stay proportional to one another when working with scale factor. Let's go and take a look at a couple of examples. The scale factor of a model car is 1 to 24. If the actual car is 18 feet long and 8 feet wide, how long and wide will the model car be in inches? So there's a couple things we need to be careful about here. Notice that the given length is in feet, but they want our answer to be in inches. So what we'll do is first find the scaled measurement in feet and then convert those measurements to inches. Let's first determine the scaled length for 18 feet. So we can use this scale factor and this length of 18 feet to create a proportion. The first ratio will be 1 to 24 must equal the ratio of the scaled length, we'll call L, to the actual length of 18 feet. And again, remember this is in feet, so our length will also be in feet. Let's go ahead and perform our cross products. We have 24L must equal 1 times 18. Divide both sides by 24. L equals 18/24. These both have a common factor of 6. So this will give us 3/4 of a foot. Now we do have to convert this to inches. Remember, there's 12 inches in 1 foot. So we can multiply this by the ratio of 12 inches to 1 foot. When we do this, the units of feet simplify out. 3/4 times 12 will give us our measurement in inches. And there's 1 4 and 4 and 3 4s in 12. So our scaled length is 9 inches. Now let's go ahead and do the same with our width of 8 feet. We'll start with a scale factor of 1 to 24 must equal the scaled width in feet to 8 feet. Let's go ahead and find our cross products. We have 24W must equal 1 times 8. Of course that's 8. 5 by 24. So we have W equals 8/24, which simplifies to 1/3, and again this is in feet. And then we'll multiply by the ratio of 12 inches to 1 foot to do the conversion into inches. And again, the reason we do this is the units of feet simplify out. This also simplifies. So our scaled width is 4 inches. So the scale dimensions are 9 inches by 4 inches. Let's go ahead and try another one. Here we need to sketch a ladybug using a scale factor of 12. That would be a ratio of 12 to 1. If the ladybug is 8 millimeters long and 4 millimeters wide, what will the length and width of the sketch be in centimeters? Once again, notice we have a change in units. This is 8 millimeters and 4 millimeters. We want to convert this into centimeters using the scale factor of 12. So we'll first use the scale factor to determine the measurements in millimeters and then convert that to centimeters. So the scale factor would be 12 or 12 to 1. Again, this is the ratio of the scale to actual length. Actual length is 8 millimeters. And we're trying to determine the scaled length. So we'll call this L. Again, this will be in millimeters. Cross products, L times 1 would be L, must equal 12 times 8. That's 96. So our scaled length is 96 millimeters. And since 10 millimeters equal 1 centimeter, we can multiply this by 1 centimeter over 10 millimeters. And the reason we do that is because now the millimeters simplify out. So we'd have 96 centimeters divided by 10, or 9.6 centimeters. Let's go ahead and do the same for the width. The only difference here is that instead of 8 millimeters, we'll have 4 millimeters. So I'll have 12 over 1. This must equal the width over 4. Again, these will both be in millimeters. So we have W times 1 must equal 12 times 4, that's 48. So we have 48 millimeters. We'll go ahead and multiply this by 1 centimeter over 10 millimeters to do the conversion. Millimeters are out. And again, notice we have 48 centimeters all over 10, or divided by 10. So the scaled width will be 4.8 centimeters. Okay, that's going to do it for scale factor. I hope you found this video helpful.